Hello, my name is Cheryl Hicks, and I'm the Executive Director in global business platform building the sanitation economy. And we started this video series to shed a spotlight on the multiple solutions that we've been working on over the past 5 years, together with the innovators, small and large businesses and organizations that have been part of the platform to hear firsthand from them where the new solutions are for the new sanitation economy. And I'm very pleased to have here with us Marc Lewis, who is with a company called AgriProtein and has also been the director of the Biocycle and Multicycle, which he'll tell us about. And this is a company that has been pioneering in new technology for waste treatment, including toilet resources. Marc, can you tell us a little bit about, or give us actually the story of AgriProtein, the Biocycle, and
Sorry, Cheryl, you broke up a little bit there, but I got the gist of what you asked. Yeah, so my name is Marc Lewis, running the Biocycle over the last 4 or so years, now working for AgriProtein. We are fly farmers. Since 2009, we've been pioneering this technology, the use of insects to recover nutrients from organic and other waste streams, and have been based primarily in the early years in South Africa, in Cape Town. And actually at that very early stage, we started out, in the sanitation sector, and the interest at that stage already was around how we can resolve some of these things. I mean, it's been an ongoing crisis, obviously, globally forever. But the potential for BSF was seen at that early stage. And we started out with a small project that we took on to support another organization around recovering nutrients from sludge. And that happened in the early stages, but very quickly we realized that there was a more simpler way to utilize the technology, and we decided to, with the AgriProtein brand, to keep to keep them very separately, to focus on a food waste recovery of nutrients. So we've done this for many years. We've been learning, failing, succeeding, all the way up to this point. Mostly our interest has been around the AgriProtein side of the business and the food waste. So a lot of our resources have gone there. But in parallel, and in 2014, we got a bit of interest from the Gates, or more interest from the Gates Foundation, and also in the impact that the eThekwini or Durban municipality were having on sanitation innovations. And we were given the opportunity to partner up with eThekwini, EWS, eThekwini Water and Sanitation Department, to set up a small pilot facility in Durban. So that was going since 2016, and had been running that works for the last 4 years.
So just to clarify there for everyone watching. So at the early stages, the processing of mixed waste, including sewage and toilet resources, was part of the original idea of the use of the black soldier fly technology. Is that correct?
That's right.
And then tell us about that, that evolution. Then I think you were just coming to that, where the partnership with the Gates Foundation, the city of Durban's water and sanitation facility, and how the separation of the wastes projects came to be, and where that is now.
So I mean, as I said, in the early stages, we were out on a farm in Cape Town, and we were able to, I'm not sure if it was legal really, but farm life, you were able to do whatever you wanted in your back farmyard. And a lot of the work we were doing was I mean, we had the fecal and the food waste mixed in a big plot next door. I mean, very close to each other. And in a normal situation, now in this situation now, we'd never be able to do that. But we were able to do a lot of that work during that period because we were so off the grid and it was so small. And so, I mean, there were perhaps 10 to 12 people running these operations. So we were able to do a lot of the groundwork in those early stages in a very confined and low cost environment. But very quickly, as the interest became more and global investment started to see the potential, then largely around removing the fish question, so replacing fish meal as an option. So it wasn't about the sanitation question, it was about how do we change the animal feed model. Can we replace a fish meal that is harvested from all over the world, global oceans, and create a more localized nutrient recovery process that could provide protein to our animals? So that's where we started to see the interest from investment.
And so can you talk a little bit more about that science of the... Sorry, Mark, I think there's a delay between our connection here. I was just wanting to probe a little bit for those watching on that science of how you are converting, organic waste into these nutrient-rich, protein-rich products for the animal feed market.
So it's quite a simple process. It's what nature does itself. We're basically mimicking a process where food starts to putrefy in the wild if no other animal or insect has come to eat it, and the BSF is flying about and it smells a certain putridity. It will lay its eggs in that environment. Other flies will also lay its eggs in that environment. Beetles will lay their eggs there. A whole number of organisms will come and resolve that crisis, which is happening on a small scale. What we do is we farm that specific fly. It's an omnivorous fly. It can eat a wide range of organic materials. It is a non-pest species. I mean, it's something that most people will not even know what it looks like, and it's become more popular now. And it's all over Facebook, all over the world. People are starting to see its value, so everyone knows what a BSF is now. And at that stage, I mean, I never even knew that a fly could look like a wasp. I mean, it's a much larger insect. But we industrially farm that fly, and at great expense and technical difficulty, have to produce a large quantity of eggs through that farming process to produce very microscopic larvae that are then placed onto this food waste, or a mixed food waste, and they grow exponentially through eating the nutrients, recovering the nutrients from that food, and they break that down. So in nature, all these different insects would do that, but in this controlled environment, we are able to create the conditions that are conducive to them being more efficient, being able to recover everything from that waste stock, from that resource that is there, and convert it into an accessible animal feed and oil. So I mean, their body is basically, layman's term, can be broken up into a protein and a lipid. And the protein is a replacement. It's largely a replacement for the fish meal product. It's not entirely the same. There's a lot of missing aspects in there, but as a protein product, it can largely replace that. And then the lipid component of their makeup, which again has applicability in the animal feed sector. It's very close to a coconut oil or palm oil, so it has application there. But it's really about how to produce those at scale and consistently, and then to resolve a constant incoming waste stream. So we have been working on that for the food waste, which is a much more regulatory, easy thing to work with. since 2000.
So I know, so you were, the Biocycle was selected as a, to be part of the Sanitation Economy Accelerator program in 2017. Can you talk about your experience in the program, what we were working on? You know, I think from our perspective, the excitement around a new technology, really new technology that would help us to both solve the sewage treatment issues at a large scale, while producing an also scarce output in terms of this high value protein products, as you just described. So, you know, a huge potential here. Can you talk a little bit about sort of what we worked on together, some of the learnings, the challenges, and where you are today?
So 2017 was a very exciting year. We thought we were on the road to large scale, so the large scale solution. I mean, it was 2016. We had just been given the opportunity to establish that facility, and we also were at that stage. We had the belief that we could sell the protein products and the products that came from this process directly into the animal feed market. We were really gung-ho, and we really believed that was possible at that stage. Not to say that we don't believe that is possible for the future now, but at that stage it was our focus and what we were going to do. So when the toilet board, when we joined this program, we were very excited to progress that, establish some markets, and try and get our facility to supply to the local sector. So the toilet board, we were able to work with Kimberly-Clark, and they helped us to map out our product, a range of products. Well, I mean, there's a number of applications, a number of products that we can, a number of markets we can go into with our different products. And there's different ways to process the larva so that you can extract more of the chitin. I mean, they have a shell, like a shell, very much similar to the crustaceans of the ocean, which are used for, the skins that are of great applications. The larva can again be used for a number of these different applications. We also were interested in the soil aspect. So I mean, the residue that remains, there's huge application there for agriculture. We just weren't sure where we needed to focus. And during that period, working with Kimberly-Clark, we were able to map out and look at what the low-hanging fruit was, what we were able to produce at that facility at the time that would get us into the market and start us to make, bring in revenues from that side. By the end of the year, it became quite clear that our expectations were a bit too great, and we had been pushing too hard to get this into the feed chain at that stage. There was a lot of work that was still to be done. So it was a big learning curve. And also for me, it was quite difficult because our focus was still very much on our food waste business, and having all this sanitation attention and interest. And I mean, me seeing how valuable this technology to the sector will be, it made me want to push it hard, and we just didn't have the capacity at that stage, number of people to deal with all the things that we needed to do to get it right at that stage. So we were able to utilize, Kimberly-Clark, their marketing prowess, their ability to sell products and understand what where you should be focusing, to hone in on what we wanted to focus on at that stage. Yeah, it was a very a very big learning curve.
And so fast forward to today, the potential, as you say, is absolutely there, and I think that the evolution in understanding since then, and what's evolved since then, and you've been a fantastic advocate for this solution, and really trying to to put in place the programs that will enable it to reach that scale and commercial viability. And can you talk now a little bit about the research? So the challenges around acceptance in the market and some of the research that you've been pursuing to overcome some of those challenges.
So I mean, this has relevance to not only sanitation. I mean, the waste sector, there's a lot of contamination in our waste. Municipal solid waste, the organics that are in there, the contamination that comes through what people throw in their bins, it's a big problem. And so the likelihood that the food waste that comes out of that process is contaminated is also very large. What we came to realize very quickly is that for the sanitation sector, there were just too many unknowns that we weren't able to, we didn't have the internal resources to unlock those problems, but we were able to focus on the big wins. So we did the research around pathogenic concerns. There was an Ascaris concern in South Africa and in Durban, an intestinal worm that was very dominant in the region, and that was something that we really needed to understand, and we unlocked a bit of that. But the big questions now are still around, the hormones that are in our sanitation system, the industrial effluents that we just aren't 100% clear on how to resolve. There are now renewed interests in resolving that, just from a water safety aspect. I mean, so there's some big companies that are focusing on it, and we are trying to leverage some of that research and institutional capacity to unlock some of those things for the feeding sector as well. A lot of the work has been done through groups like EWAG and RTH. I mean, the many universities are starting to focus on the persistent organic pollutants and the issues that are in the system, and it's something that we will continue to work closely, with these organizations, these institutions, to resolve those things.
Thank you, Marc. So, I think black soldier fly technology as a solution for waste treatment, as a solution for food systems, nature-based solution, with huge potential, and really the challenges to unlock are around the safety. The safety, answering any unknown questions or unknowns around the safety of the end product, and so in terms of the future outlook, or what is required in order to overcome that hurdle, and when do you think that we'll be in a position to see this moving forward with the speed that you'd originally envisioned?
I mean, I think what's happening now globally is that there are many more small companies doing some of this work, and the reality, the more the wave, the drive, and the more interest that comes with this, the more resources that will go to it. There's a lot more research that's happening, so a lot of the questions that we couldn't answer ourselves, and that they're starting to be answered. For us, it's not a matter of, I mean, it is a matter of application. I mean, where can this protein be placed? I mean, the reality is that a large scale facility is not going to produce that much protein, and there are definitely applications into which a facility can put a protein that isn't directly a feed ingredient, but it's whether it makes sense for that locale. Does a municipality, is there a gate fee model that can work, that will make the business a viable business? It's really about finding that perfect collaboration, I guess, as well as a market that's accepting of some of the products. it's about developing that. We don't want to push into that route yet until we can really produce enough larvae to make it viable, and that's where we are sitting now.
And can you talk about the markets that have been interested or are interested? I mean, who is this relevant for in terms of the commercial side? Who can sectors and industries?
So what there's a lot of fertility products where protein is added. So fish meal is added to a lot of fertilizers, and we found that there's a big potential for adding that protein into that sector. I mean, where there are small depot, bagged fertilizer industry, if it's a thriving industry, that would make sense. Around, I mean, again, agriculturally it's required. Where municipalities are utilizing their sludges on, in agriculture, this process can beneficiate that. It can stabilize the product further, it can improve it, and it can be applicable. But it's about finding those relationships and having the right partners to get it done.
And so, the fertilizer industries, others, I know we were in dialogue over the years regarding many other industries. Can you highlight those as well?
So I mean, the feed sector is something that you can go into where it's a non-feed application. So if you're feeding directly to an animal that's going to be eaten by a human, it's not necessary to go there. So day-old chick production is an example where you could be supplying that industry. Any sort of animals that aren't used in the human feed chain, there's application there. We've also looked into producing glues with the protein. I mean, if you isolate the protein far enough, there are a number of applications that you can work in. Similarly, we've been extracting the chitin, and the chitin has application in water filtration, the water filtration sector. There are polymers that can be made around that, but here it's about a quantity. So if you really need a really large scale process to produce enough to warrant any sort of viable product, and that's why getting this understood commercially on a much larger scale is important.
And aside from the food sector, other applications, I mean, proteins go into cosmetic, food products. Can you talk about the exploration of the application for some of those non-food sectors?
So the extracted oils can go into, I mean, lubrication, and there's a thriving interest in Asia around its application there. We've looked at biodiesel for the oil as well. It's not ideal for that because it's such a quality oil, and it solidifies at temperatures that wouldn't be great for your engine. But they are, if you separate it out far enough, you would have application there. Yeah, I mean, it's more around the fuel aspect for the oils. The proteins, you can also isolate even further the proteins, and then you're left with a much more stable and a safer product. So, I mean, we're still not really pushing into any market now because we're not able to produce enough quantity. So we will leave that until 2022.
Thank you, Marc, for spending this time with us and really, you know, explaining this opportunity, this new technology that has the potential to really solve for multiple global challenges, including sanitation and waste treatment, including you know, the proteins for the food sector, all with a nature-based solution. And as you're saying, there's, you know, potential for multiple applications across multiple industries. So you know, at the Toilet Board Coalition, we're really needed to be able to really be able to apply this solution as a solution for multiple challenges, including sanitation. So thank you, Marc, for all of your advocacy and all of your hard work on developing this new solution, and we're so happy to continue to partner with you.
Thank you, Cheryl, and thank you to Toilet Board. I mean, it's 2017, it's now 2020, and the growth and the expansion of the interest globally has really been largely due to your inputs. So great work. Great to be a part of this program.
Thanks, Marc.